The paper of the day is Access Path Selection in Main Memory Optimized Data Systems. Should I scan or should I probe? It's a 2017 paper. This paper demonstrates that access path selection is still required since both secondary index and sequential scan access can prove beneficial for analytics. As more in-memory access paths are developed, access path modeling and the selection remains a key challenge in modern analytical data systems. Paper shows that, contrary to traditional approaches, access path selection should not use a fixed pivot point based only on machine hardware and selectivity. Instead, in order to decide the access path for a batch of queries, a system should take into account the following two dynamic parameters. First, the selectivity of each query from the batch, and second, the number of concurrent queries. Finally, they demonstrate that the APS, that is access point selectivity, is a lightweight process that does not negatively affect the execution time even of low latency queries. In terms of benchmark, the experiments run on the data generated for the TPC-H benchmark. There are quite a few lessons from the experiments. In total, there are 7 of them which are mentioned in the paper. Lesson number 1. There are cases for analytical queries when a secondary index scan is preferable to a sequential scan even when the data is in main memory resident, which removes the disk I/O bottleneck. Lesson number 2. A fine-grained access path decision needs to take into account as a runtime parameter query concurrency, in addition to selectivity, hardware specs, system design, and data layout. Third, dataset size can be pivotal. For small datasets, scanning the data outperforms secondary indexes in all cases. Index remains useful for larger datasets as full attribute scans become costly. Lesson number 4. While the crossover between the access methods is lower than in the past, it still corresponds to a growing result cardinality. For example, a query that selects 0.6% of 500 million integers has 3 million qualifying tuples. Lesson number 5. While sharing data access minimizes repetitive reads, it concludes the overhead to distribute the results to their consumers. Result sharing is efficient up to a batch size because of the bookkeeping and the result distributing overhead. Lesson number 6. Access path selection is important for systems with columnar storage. However, it becomes even more important for wider tuples in hybrid stores. Lesson number 7. As the cache and memory latency decreases or the memory bandwidth decreases, secondary indexes become more beneficial. On the contrary, slower caches or memory and faster memory buses benefit scan. In this way, future hardware generations can affect the balance between these hardware properties, will also affect access path selection accordingly. These properties are captured by the APS model. Coming to contributions, there are 6 key contributions of the paper. First, they present an augmented access path cost model that captures the performance of select operators in main memory optimized analytical data systems that support access sharing. Second, they show that access path selection is needed. Tuned secondary indexes can be useful even when fast scans are deployed. Third, they show that in addition to selectivity and hardware characteristics, access path selection needs to dynamically take into account query concurrency. Fourth, they integrate access path selection to the optimizer of a modern analytical prototype and show that even though access path selection is now a more complex operation that must take into account more information, it can be done quickly enough that it remains beneficial, even for subsequent queries. They demonstrate that access path selection can be done on a variety of workloads, outperforming solutions that rely on a single access path or on traditional access path selection models. Using the model, they show that how the decision of when to use an index has changed as the data layout and hardware properties have changed over the last 5 decades. Coming to PS score, overall it's a really nice read but has bumpy parts because of the math, so it gets 6 out of 10 on readability. With 16 pages long, it scores 7 out of 10 on length. Reproducibility and repeatability will be challenging, so it gets 7 out of 10. Industry value and learning meter is decent, so it gets 7 out of 10 on each. Overall PS score is 7 out of 10.